started for those who can't join. So first up, in terms of evaluations, I don't know if you could see that before it booted me out. You guys are almost there. 19 out of 23 of you have completed a course evaluation for the university. Two more, and everybody gets one more extra credit point. I haven't tallied up the surveys from Qualtrics yet. I'll do that at the end of the semester. You have until the end of this week to finish the university course evaluation, and you have until the end of finals week to finish the separate one that I'm asking through Qualtrics. So don't have to get these done right away, but as soon as we hit this barrier, I'll let you know. The other class is still just slightly ahead, so they need two more people as well. Let's see. So that's that one. The next thing I wanted to do was go over homework 5. So by now you've had a chance to look at your scores. Right after it finished, I caught a typo. So this is one of the reasons why the scores don't update automatically. I go through it myself and make sure that everything's okay. And I actually caught 2 mistakes in the answer key, and I fixed those. And so the current version should be correct. If you come across any others, please let me know. But I thought it would be useful just to go over some of the drop-down questions. Would that be helpful? If not, you can say so, but a little review maybe not a bad idea. Oh wait, chat window, make sure I've got that open. I vote for yes. Okay. And if it's not helpful, you can just, do your email or go stretch or make a snack, whatever a good use of your time instead would be if you feel like you got this under control. So the definitional ones here. This is homework 5. It's a hierarchical model building exercise starting with an empty model. So this is section 1, in which we're just predicting graduate school ratings with no predictors. So at this point, what's in the model is the fixed intercept and the residual variance. And so I was looking for to recognize that if there's no predictors in the model, the fixed intercept is the sample mean for the outcome. That's what it's telling you. If you know nothing else about a person, your best guess for what their outcome is going to be is the sample mean, the middle value, or middle is medium, not median, middle. This thing right here, the residual variance, and so in this person's assignment, this was the exact number, but for all of you, the definition is the same. It is the squared average distance of the case from the sample mean. So variance is describing differences across the people within your sample. And variance is a squared metric. It has to be squared. That way positives and negatives don't accidentally cancel each other out. And so in the empty model, the residual variance is actually all of the variance in the outcome. So that is as much information as there is to be predicted. That residual variance should then go down as you add predictors, which means that you've reduced the unexplained variance, you've accounted for some variance. So as residual variance goes down, you see that as R-square going up. So at this point in the empty model, it's all the variability that there is to be had. R-square would be 0. And so then I had you add a predictor for motivation. And these data were simulated such that there was a positive slope for motivation. And so the question is, how much variability did motivation account for? At least some. If it's a significant slope, then you have a significant model. So at this point, the model is the same as the slope. The t-value for that slope would be telling you the same information as the f for the model. And the standard error. So a few of you missed this consistently. Standard error is an unsquared metric. So when you hear the word standard, like standard deviation is the square root of variance, standard error is also an unsquared metric. And standard error is meant to convey the expected inconsistency of that statistic across samples. So what it's trying to approximate is the average deviation of the sample version of whatever you just found from the population version. So we can have standard errors for the intercept, we can have standard errors for the slopes, and in subsequent classes, we'll have standard errors for the residual variances as well. We will start to see those once we move into likelihood estimation. So this idea of a standard error is an abstraction at one level higher. It's talking about how the results for your sample would be expected to vary across repeated samples, even though the information that we use to calculate the standard error is coming only from your sample. People smarter than me have figured out mathematically a way to get that level of abstraction across samples, even when you only have just one sample's worth of data. So standard error is unsquared. It's the average distance from the population mean of the sample version of that statistic. Okay, questions or thoughts on that? By the way, if you have a standard error squared, the term for that is sampling variance. So you may hear that term used in quantitative research to describe the behavior of a statistic across samples. Its sampling variance is its standard error squared. But that's not something that you would typically report as part of a results data analysis section. Okay, so then section 3, adding in the effects of GRE scores. So adding 2 predictors, which means that to get a test of their simultaneous contribution to the model, that's an F-test that you have to request via contrast or test. So that was really the one new thing that this homework is bringing. The model that simulated these data indicated that GRE verbal score does not matter, but GRE quantitative score does. So that's the underlying model that all of you have. And so we go through the process of fitting those 2 slopes, trying to figure out whether the model itself is significantly improved. So there is first this F-test with 3 degrees of freedom. That is referring to the test of the model, so whether or not the overall R-square is better than 0. And that's followed by a test specifically for the addition of GRE. And so that F-test is referring to the change in the R-square relative to the previous model. And we have the standard errors, we have the directions of the slopes. So just to remind you, how you choose between significantly higher, non-significantly higher, etc., etc. Higher or lower has to do with the direction of the slope. So if you have a positive slope, that means the outcome is predicted to be higher with increases in the predictor. If you have a negative slope, that means the outcome is predicted to be lower with increases in the predictor. Significant versus non-significant has to do with the p-value that corresponds to the test statistic. So a p-value that is greater than 0.05 is non-significant, meaning that it is sufficiently expected to happen given regular sampling fluctuation, whereas a p-value that is less than 0.05, so less than versus greater than or equal to. Less than 0.05 means significant, means that is the probability that you would see the result in this sample if the null hypothesis was true. And so if that happens with sufficiently low probability, we say that the result is significant, unlikely to have come from the distribution characterized by the null. Okay, questions on any of that? Okay, last but not least, fear of statistics. So the story behind this, as you might imagine, little, moderate versus severe. Little versus moderate didn't matter, but having severe fear is related to lower outcomes. Being afraid of statistics is not a good thing. But none of you are afraid anymore, right? You may not be best friends with statistics, but hopefully you've gotten to know them a little bit and they're not as bad as people say. Not as bad as you would have feared. That's what I'm going for here. So if you set up the codes for this fear group variable in the way that I had intended, If you created coding scheme that distinguishes little from moderate and then moderate for severe, then you would have been able to use the model directly to answer all of these questions. You wouldn't have had to write anything else. If you coded it such that little was compared to moderate and little was compared to severe, which is the demonstration that there was with dementia group, that's what it was for golf group, etc., then you would have had to write a lincom to get moderate versus severe, but that's fine. If you did it that way, it's still the same model, just a different version of how you rearrange it to get the parameters. And that would be the end of the story. So any questions on anything in homework 5? No. Okay. So then homework 6, move this thing out of the way here, just one second. I have this one here. Homework 6 is about the skills involved in playing Scrabble. This has a story behind it. Would you like to hear the story? Okay, this story comes back almost 10 years or so. I was on vacation with my now husband, and we went into Sanibel, Florida. It's like an island that's really in the south. We went over New Year's, and we rented a little Airbnb place, and we were looking for things to do. And inside the condo that we rented, they had board games, and one of them was Scrabble. And I had actually never played Scrabble up to this point. I had heard of it, I had never played it. So we got it out and we started playing, and I realized that I am terrible at this. I am terrible in ways that I couldn't even understand why it was so bad. And it took me a while, and eventually I realized it's not just about making words, it's about where you place the words. You have to figure out where to put the cue on the triple or the triple word score. And so I was focusing too much on making words and not enough on where I was placing them. So we played Scrabble, and he beat me just like terrible, terrible margins. And after we got home, we discovered the game Words with Friends. Do you know this game? See if I can pull it up on my phone here. I call it phone Scrabble. I usually have 2 or 3 games going at any one time with my mother, my aunt, sometimes my brother, and my husband. So yeah, Words with Friends. You can see the app here. It's loading. Phone Scrabble. So we started playing it this way instead because the board was a lot easier. This board's easier. You don't have to do the math and stuff like that. So yeah, as you can see, I am currently beating my mom. There's a game waiting for me to play. It's my job to help her with Alzheimer's. This is me engaging her cognition, for her own benefit. But anywho, fast forward a month or so after we've been playing phone Scrabble, and I'm still very terrible at it. And we got the chance to go back to Florida, but on a business trip. So I was part of the executive committee of the Society for Multivariate Experimental Psychology, and they wanted to have a mid-year business meeting at the location where the conference was going to be hosted, and it worked out to be this resort in Florida. And I'm like, paid trip to Florida in February? I think we can swing that. I'm okay with that. So the meeting was only going to be like one day, but we booked a couple extra days, of course. And so there was one glorious Saturday. The weather was absolutely perfect. I got to spend the entire day inside a windowless room, like in an over air conditioned hotel, listening to old men talk. That was my recollection of the meeting. And my now husband was on the beach. He got to spend the day at the beach. And so when the meeting was over, I sent him a note and he came back to the room, and he comes back with this drink that's like at least this big. It was called a rum runner. I don't know if you've heard of this. Oh, okay, recognition, yeah. It's a drink that's like a big gulp sized drink that about this much of it is alcohol. It's sort of like a Long Island where they put everything in, and it's just, a big drink. And he's carrying this, and he's like, "Hey, baby, how is it going?" I'm like, "Oh, how many of these have you had today?" He's like, "4, I think." So he comes in, he sits down, and we're hanging out. There's 2 different beds in the room, and we're playing phone Scrabble. And his day is catching up with him because he's plays a word, and passes out. And then he waits till the phone dings. And it's like, ding. looks up, looks at the board, plays a word, passes back out. And this whole time, he is beating me by like 200 points. Like he's just killing me, right? And I'm getting angrier and angrier. I'm sitting here like, how are you still beating me? You are passing out between turns and you were still killing me. And he wakes up and he goes, I'm fucking gifted, and passes back out again. So I personally am not fucking gifted. I'm just not. So the moral of the story here is if you're going to play Scrabble, especially with a difficult opponent who is fucking gifted, you got to have spatial skills and verbal skills. And the effect of having good spatial skills matters more if you're playing a difficult opponent. So that is the background story of your homework. Spatial matters, and I have terrible spatial ability. So high stakes Scrabble, that's the thing here. So yeah, good times. And by the end of the semester, I know it's easy to focus on the questions that you don't get right, right? Like you scroll through here and you're like, you see the red and it's like, oh, I hate that I messed that up. I want to tell you guys that you, by the end of the semester, you will have completed 459 questions. I added this up the other day. So you know what? If you miss 2 or 3, who cares? You got hundreds correct. So feel good about that. Even if this is hard right now and you struggle going through it because you've never done this before and it takes practice, just remember that. Think how far you've come. So, not to get all like, mushy gushy on you, but I'm very proud of you. And I hope that you're not afraid anymore because this stuff is fun. So, are we ready to talk about interaction terms? Yeah? All right. So, let me pull up the starter kit that I made you. So I sent you a link to this document via email this morning. It's also posted on the webpage. Yes, hell on earth is an overly air-conditioned room listening to men talk. It was a long day, but it's what I had to do to get a free trip to the beach. And I spent the next couple days at the beach, so it was okay. So here's my little story problem. This is the equation that we're working with. So we have 4 distinct predictor variables in this equation, which I've labeled F, G, H, and I. We have their individual main effects. So the beta that's tied to that predictor all by itself is referred to as a main effect. And then we have 2 interaction terms of F and G and F and H. So I asked you to do various things with this equation to determine how it predicts outcomes for particular kinds of people in the first question, as well as slopes for the predictors as according to the model. So I've written that equation out right here. So this is just the equation printed again so that we can take it apart and rearrange it as needed. So if I'm going to discern how the model predicts an outcome for a certain kind of person, what I'm talking about is y hat. I wrote it out here because I couldn't find the caret. But y hat is just the fixed effects without the e. So when you're making predictions given predictor values, but it's not the same thing as the original variable because the original variable has the error in it. But these statements are all just about predictions, and so the e residual is not a part of any of this. So just predicted values based on fixed effects. So I wrote an equation here for us to figure out what goes in the blanks. So if I'm predicting for someone with an F of 2, G of 3, H of 4, and I of 5, what goes here? 2, because we're filling in the value of the predictor for which we want a predicted outcome. So 2 goes here. What goes here? 3. This one is 4. I made the numbers like this so it would be easy to remember. What goes here? 2 again, because it's just replacing F, and G is 3, and the last one is a 2 again, and the last one there is a 4. So this is how the model tells you what Y would be for that kind of person. Note that it requires every single fixed effect that's in the model to generate a predicted outcome. So now the question is, how do we tell SAS or Stata this information? How do we make it do that equation? So the words, the part of this line that's written here, those refer to the betas. So what goes next to them are the numbers that we just put in. And Stata's version looks like this, where we have the plus signs in between and the asterisk denoting multiplication. I'll go ahead and fill in that version. What goes here? A 1. Now, do I really have to type times 1? No, I don't have to. The reason that I do that is because I'm trying to go for symmetry with what it looks like in SAS, where you do have to type a 1 there. And so when I type intercept 1, what I'm saying is build into my prediction 1 of the beta zeros. Beta 0 doesn't have a multiplier. If it did, it would be just a column of 1s that is a constant for everybody. So I need one of those. What goes here after F? If I'm making a prediction for somebody with a 2, yeah. So the numbers that go after your variable names are the values that you want multiplied by those betas. So 4, I is 5. What goes here? F times G, 6. Yeah, you have to do the math. SAS will yell at you if you try to make it do the multiplication. And what goes here? People putting things down to get enough fingers. Yes, 8. Good. So this is what it would be like to figure out how to get a predicted value for any type of person according to the model. The model tells you what it should be based on any combination of predictor variables. So key to understanding how to write the code is recognizing that when you're asking for a predicted outcome, absolutely every fixed effect that's in the model goes into the prediction. If you leave out a particular fixed effect when you're creating a predicted outcome, you are setting it to 0. So when you make a predicted outcome, the intercept goes in and all main effects and all interaction terms, everything. Questions on that? All right, next one. So most of you got the first one correct or reasonably close. This is where we had some variability. So write the equation and a statement for the predicted G slope for somebody with f of 2. So here's my equation again that has everything in it. What's my first step? How do I figure out what is going to contribute to the predicted G slope? Factor. That's step number 2. Before that, I got to figure out what I'm factoring. Yeah, find the terms that have the predictor in them. All of them that have that predictor, but only them. So if I'm asking about the G slope, so don't worry about the for f of 2 part, just what am I asking for? I want G slope, okay. So do I need the intercept? Nope. Do I need the main effect of f? I don't. And this is tricky because you're like, but it's for somebody with f of 2. No, f is the moderator. I want a g slope. So only things that have g. So yep, it's going to be beta 2 plus beta 5. Two pluses. There we go. Those are my ingredients. Now comes the factoring. So I'm going to make an arrow here. If I pull G out, because that's what it's going to be in the back, what I'm looking for is the term that goes in front of it as its slope. What I have left is beta 2 plus beta 5 times f. So a lot of you recognize that it would be beta 2 plus beta 5, but in particular, we can't forget that part. Beta 5 still has f as a multiplier. So the effective g in this model is given by beta 2 at a minimum, and that would be the effective g when f is 0 specifically, because that's when the second part would drop. But I have to keep the f attached because that's going to be my multiplier to be able to customize my g-slope for what kind of person with respect to its modifying predictor. So it's beta 2 plus beta 5 times f. That is going to give me the right ingredients to get to the g-slope, according to this model. Okay, with me so far? So then when it comes down to implementing this thing, do I need an intercept? No, I got some disagreements. Yeah, I need an intercept if I'm creating a predicted outcome. I do not need an intercept if I am creating a predicted slope. We are creating a slope, so I do not need an intercept. Another way of asking the question is if I look up here at the ingredients that create my g-slope, do you see beta 0 in there? Beta 0 is not in there, so I don't need an intercept. So I'm going to get rid of that. Do I need the main effect of f in creating my g-slope? Do I need beta 1? Nope. If there's no g in it, it's got to go. Do I need a main effect of g in creating my g-slope? Yes, I do. How many of them do I need? Just one. 1 beta 2 corresponds to the idea of putting a 1 there, because I am referring to the effect of g in this line, which is beta 2. Do I need main effects of h or I? Nope. Or said more simply, do you see a g there? Nope. I don't see a g. I do see a g in this one. So what goes here is the value of the moderator. What value of f do I want the g-slope for? And in the instructions, it says an f of 2. There we go. And do you see a g there? Nope, it's gone. And so that's all that's left. And so if I were to do the same thing in Stata, get rid of that. I need 1G. I got an F hashtag G that goes to 2, and that's out. Okay, so the 3 steps then. Identify the terms that have the slope in it that you're trying to get. Factor out the common, and then see what's left.
Okay, so G is 1.
Mhm.
I'm trying to check that. I don't know why. G is 1 because I don't know. That's the slope we're looking for?
Yes.
Oh, okay.
Yes.
Good
So
guess, Deb.
no, this is what is so hard to explain about this is that sometimes the numbers are referring to the value of the predictor, and sometimes they are referring to the slope. And so, yeah, whatever you're asking for, it starts off with that thing and a 1. Because I'm asking for the G slope. So at a minimum, I need 1 G slope. The question is, what else do I need? And so this 2 here is referring to the value of the moderator for which I want the G slope. So 2 is referring to the value of the predictor, not a slope. It's the multiplier. So the numbers are acting differently, which is hard to wrap your head around.
Lisa, I have one quick question too.
Yep.
Do we still need to add the 2 parts together? Like, so we have G1 plus F times G? Or does
It's
that?
G1 refers to 1 beta 2. So whatever beta 2 is going to become by fitting the data and estimating the model, that's what G1 refers to, is that slope as the core ingredient.
Okay.
And so then the other half of it that does need to be added to it is beta 5 as a function of F.
Okay, so in the estimate or the Lincom statements, we don't need a plus sign between the 2 parts?
Oh, I see what you're doing. Yes, you do. Thank
Oh,
you.
I think I wasn't clear on what I initially said. Yeah, on the
Yes,
estimate.
in Stata you do.
Okay, perfect.
Yes.
Thank you.
Yeah,
Those
so
are the things that trip me up. Okay, perfect.
yeah, so this little piece of code here looks almost exactly like in structure to what the ingredient is from the
Sure.
equation. Like it's making
Yep.
it explicit.
Okay, that makes sense. Thank you.
Thank you for the question and for catching my error. Okay. Are we ready to do another one? Okay, so F slope. Step 1, find all the things that have F in them. So at a minimum, I need that. If there were no interactions in the model, I'd be done. Because F is involved in interactions, I'm not done yet. In this case, F is involved in 2 distinct interactions, so they both go in. What's next? Find all the terms that have the slope in them that you're interested in.
Lisa, really quick question.
Sure.
So, why wouldn't we have just brought down beta 2G and beta 3H? Because it doesn't have the F in it?
Correct.
Okay, got it.
Yep. We're looking for the F slope. If F is not involved, it's not relevant. Exactly right. And for the same reason, we didn't bring down the intercept. Yep. Next step is factoring. Pull F out and keep what's left. Beta 1 plus beta 5 times G plus beta 6 times H. Now that gives us our ingredients to make an F slope. So now we got to look up at the instructions and say, okay, for whom do we want the f-slope? G3 and H4. So that tells us what to put in the parentheses. That would then be implemented in the lines here. So I'm going to get rid of the intercept. I'm going to get rid of G, H, and I because they don't have F in them. And that's what's left. So what goes after the F? 01, because that's the thing we want. What goes here is the moderator. So it's the value for G for which we want the f-slope. And in your instructions, that was 3. Likewise, what goes here is the value of the moderator for which we want the h-slope, or the f-slope, which is h equals 4. And that goes there. So we're left with f1, f by g3, and f by h4. And if I do that on Stata, get rid of all the things that don't have F, fill in the moderators. Now I've got my F slope. Okay, questions? The last one. Yeah. Okay, what's finding the I slope for somebody with F of 2, G of 3, and H of 4? What's step 1? I'm looking for the I slope. I got to find the things that have I, right? Okay. I got the main effect of I. Do I have anything else? I'm done. So this was a bit of a trick question, but I'm trying to make a point. The label that I would use to describe this is marginal, unconditional. This is the I slope for everybody, according to this model. So I could have written out whatever values, and it doesn't matter. The model does not differentiate the I slope as a function of F, G, or H. So I wouldn't have to ask for this. It would already show up on my output. But if I did want to ask for it, the only term that I would have is just I. And that's it. It's not a linear combination. It's a constant, one number.
Lisa, why wouldn't you have the intercept?
Because the
Because it's
intercept
not.
doesn't have I in it.
Got it. Okay.
Well, the word does, but
Got it. Okay.
beta 0 doesn't have I in it.
Great. Okay. Thanks.
Yep. There's no I in team. That kind of thing. Right, team? So questions on any of this?
So on Thursday, I think is when we first talked about this.
Yeah.
We did like education equals 10 and things like that. How is that different? Because I think that was my main point of confusion. I was trying to actually do more math, maybe. I don't even know what I was trying to do, but we were trying to find like education. Oh no. Yeah, education is 10 or 18 or attitude is 2 or 5. How does that differ from what we were doing right here?
Other than the fact that those are words instead of letters, it does not differ at all.
Oh, okay.
Yeah, and centering, I did no centering on this just to try and make it as easy as possible. But the other part would be whether or not you've if it's education equals 10, is that relative to a centering point of some other number, or is it just 10 relative to 0? You'd have to figure that out to get the values correct, but otherwise it's exactly the same. And we can go back over that if that would be helpful to see it again after going through this process. Question. Okay. All right. Do you want to talk through those slides again real quick or not real quick?
I think I'm okay because right now it makes sense. And if it's really just a centering thing, I think I'm okay.
Mhm.
Unless we'll have to center on the homework. Then that might be.
In the homework, the modifier, the moderator is a 0, 1 variable. So a sort of centering, but not really. Coding, I'd say, rather than centering. But yeah, like what you're talking about here is exactly on the same ideas as on slide 18, which I just pulled up. So this example had one interaction term in it. So it was actually simpler than what we just did. And we have attitude slope for different levels of education. The intercept's not involved. The attitude slope is involved. The main effect of education is not involved because it's the attitude slope we're going for. And then the value for the moderator is relative to the centered version of the predictor. So it's -2 because education has been centered at 12. And then the same is true in the opposite direction for the education slope. The intercept and attitude slopes don't contribute because they don't have education in them. The education slope is the thing we're asking for, so that gets a 1. And then the values of the moderator are for attitudes, relative to an attitude of 3 as a centering point. Okay, does that help?
Yeah, that does. Thank you.
Okay. And we have an example to do that is not coincidentally very, very similar to your homework 6 model. So we should be able to get through at least part of that today. Okay, other questions before we jump into that? All right, then let me pull up example 6. Somewhere in here, I've got 7,000 windows open, but they all serve a purpose. There we go. Okay, so I have example 6. There are, I think, 3 different models in it. The first model is a main effects model, and then I have a 2 interaction model and then a 1 interaction model. And so we may not get all the way through today, but we should get through enough to get you started on homework at least. So these data are the same that were introduced in example 5B, but I don't think we've talked about them in class yet. So these are fake data based on real data. So these are data from fictitious older adults, 550 of them, who are between the ages of 80 and 100, and this is thought to be the baseline observation of a longitudinal study. So the predictor, or the outcome rather, that we're predicting is cognition, which is indicated as a measure of crystallized intelligence by something called the information test, which is like a test of general world knowledge. It's something that should not show any change unless someone is having some sort of cognitive decline or dementia type of deal. We're going to be predicting that cognition outcome from age, which we're going to center at 85 years. We're also predicting it from grip strength, which sounds sort of weird, but that is a commonly used proxy for physical condition. It's measured in pounds per square inch that you can squeeze on the little device, and it's centered at 9 pounds, which is near the mean for the sample. I've also got biological sex, men versus women, as a binary predictor, and then subsequent dementia status. So within this sample, some of the participants will never be diagnosed with dementia. That's the none group, which will be our reference. Some will eventually be diagnosed during the longitudinal study. That's the future group. And some have already been diagnosed, which is the current group. And so since this is a 3-category predictor, how many slopes am I going to need to create? How many predictor variables am I going to need to create and give it slopes? to distinguish my 3 categories. It's 2. It's always number of groups minus 1, because the minus 1 is because the intercept is going to cover one of the groups. So the intercept is going to cover the reference, so we got to get to group 2, and then I got to get to group 3. So 2 slopes will give me all 3 mean differences between the 3 groups. So the way that I'm importing this data is different than what you've seen all semester. I am showing you what it would look like to start from a file format that's already in that program type. So how to import, say, a SAS file into SAS and a Stata file into Stata. Up to this point, I had done Excel files because that way you could look at them, but I wanted to show you what this would look like from a native file format as well. So in SAS, there are 2 things that are different than usual, and I've highlighted them here. In SAS, we have to create a directory, what's known as a library, a location that holds SAS files. And so that is done with this libname statement. I have created a location called FileSave. So it's the exact same location that I have referred to up here. Note that I have the ampersand FileSave period reference. So it, when it reads that, is plugging in this file path into here directly. So I have this generic representation of FileSave that could work for any kind of file. I can use that in any kind of import or export statement. This representation under libname is specific to SAS datasets. So then when I go to import the example data, the way to read this is when you see the word data, that means make me a new dataset. I'm going to put it in the work temporary file location. I'm going to call it example 6. The word set means from. Where the data are coming from is right here. That refers to a place. So that's the place I had defined just up above. So when SAS reads that, it understands to go to that folder and look for a SAS file. And the name of the SAS file that it's looking for is SAS_chapter 2. So this is from my textbook. The way that I named files was the program and then which chapter they came from. Note that there is no extension. So there's no dot like XLSX or any of that. The extension for a SAS file is SAS7B.dat, which sounds crazy. And I'm honestly not sure where the hell that came from, but that's what the extension of a SAS dataset is, and you don't have to type it. So what this is doing is starting with a SAS file in the file save location called SAS chapter 2, making a copy of it in the temporary directory. It's going to be called example 6. The reason that I am doing this, those of you who are going to work in SAS, listen up. SAS lets you empty your data set. There are no like stop gaps. If you do something to data and you mess it up, it happens immediately. Like you can empty your data set. So the very first thing that I do is make a copy and work with the copy so that the original data set stays safe and sound. And yes, I have done this before. If there's a way to screw it up, I have done it. So I'm hopefully trying to keep you away from the same fate. So I am working with the copy and creating centered variables. So this is what it would look like to subtract a constant. So age 85 is my new 0 point, grip strength equals 9. Just as a reminder, it's a new column that goes before the equals. So that's the name of the new column. It needs to be a different name. The original name of the column that it's coming from is after the equal sign. And then I'm creating 2 dummy codes. So in your homework, you only have to make 1 new variable because you have easy versus hard Scrabble opponent. So there's only 2 possible values, which means there's only 1 slope that is needed to distinguish them. So yours will be simpler than this, but this is a 3-group example. where the one group is the reference, and I know that because the new variables I'm creating are both zeroed out for the one group. The first variable is going to distinguish group 2 from group 1, which is the future group. And the second variable is going to distinguish group 3 from group 1, which is the current group. And then I've got my labels and my filter that kicks out any cases that don't have all the variables I'm going to be using in the example. So any questions on the SAS code? Then we'll do Stata next. Okay. Stata, folks. Your import code looks slightly different. It used to be import Excel, and now it's just the word use. And note that you do have to provide the extension of your file names. So Stata Chapter 2 is the name of the Stata dataset. It has a DTA extension that you have to refer to. So the combination here, the $save files, $sign file save is referring to the directory defined up here. And then the name of the Stata dataset is right here. And having clear means that if you screw something up in your data set and you need to start over and re-import it, then that allows you to do so. Otherwise, it gets angry that it's already open. And this is not actually saving anything to the data set. So when you get done with your Stata session, it asks you if you want to save the changes to your data. You don't have to. But that's good because if you screw something up, then there's a back door you can get out, unlike SAS, which does your data changes automatically. So I'm making 2 new centered variables. For the purpose of getting a semi-partial eta square effect size, I'm also literally creating the interaction term that's going to be fit in that example. That's not something you need to do, but it's something I had to do to get effect sizes for this example. And then I have my dementia group contrasts, so creating the 2 empty variables and then changing the values to 0 and 1, conditional on each of the groups. And then I've got my labels. So any questions on Stata code? Okay. So the first model in this example is a main effects model. And I used this one to demonstrate how to get predicted values for different kinds of people. So the model that we're starting with has main effects of age, grip strength, gender, and dementia group. That means without interaction terms, each of these main effects is marginal. More question. Marginal, unconditional, is the slope for everybody regardless. So if we look at this from the lens that we just used to view the last formative assessment, age shows up in one place. Grip strength shows up in one place. So beta 1 is the effect of age, period, for everybody. Beta 2 is the effect of grip strength for everybody. So this is a marginal main effects model where each predictor has its own slope, and the slope is for everybody. We would also describe these slopes, in addition to being marginal, as being unique effects, though, because beta 1 is the effect of age after controlling for grip strength, gender, and dementia group, and the other slopes are after controlling for every other predictor that's in the model too. So unique, but marginal. And so here is what it would look like in SAS if you wanted to create predicted outcomes for different kinds of people. Here I'm demonstrating low, medium, and high values of age and grip strength based on their standard deviations, holding gender and dementia group constant at men with no dementia. Here's an example of the main effects model. So what's that right there? 88 tells me what? I'm eagerly awaiting the chat window. This is not a finger question, unless you're exceptionally good at sign language, which I am not. What's that? 88. MSE, correct. What else could I call it? Residual variance, conceptually, what is it telling me? Leftover variance, yeah. What is unexplained? Yeah, there you go. How much information and cognition do we still have out there that we don't know why it's there? Why do people still differ from each other that isn't their age, their grip strength, their gender, or their dementia group? Is that good? Is 88 a lot? Eh, Is there anything that would tell me if it's good, bad, or in between? Yeah, so Stata people are looking over here to find it. SAS people can find the answer to my question here. What's this thing? 0.27. Yeah, proportion explained. So 27% of the original variability in cognition was explained by my model. So that helps contextualize what 88 means. 88 is the amount of variance that is unexplained. It is 1 minus 0.27. So does my model significantly explain variance? Is 27% better than 0? Survey says, yeah, that's my F test. Where did the 5 come from here for numerator degrees of freedom? Yeah, number of predictors, question mark? Yeah, number of slopes. There are 5 variables, each has 1 slope. There are 6 fixed effects altogether because we also have the intercept. There are 544 more slopes I could have put in the model because I have 549 people altogether. And so then we have the estimate standard error. Those two divided by each other gives me the t-value, which gives me my p-value for each of these effects. So 29 is the predicted cognition score for someone who's 85, who has 9 pounds of grip strength, who is a man, who has never had dementia. And I know that because that is where all the predictors are 0. That's my you are here sign. So for every year older, cognition is predicted to go up or down. This is a finger question. Yeah, down, because it's a negative slope, down significantly. Yeah, all of these are significant. Not surprising with 550 people. For every pound more I can squeeze on the thingy, cognition goes up. Yeah, positive slope. Here is my gender variable. It is coded such that men are the 0 and women are the 1. This is a binary representation. Who's higher, men or women? It is a negative slope estimate. Who's higher? Got 1 vote for men. Anyone else want to vote? Sounds good? It is. Men are predicted to be higher. So how I know that is because women are the 1 group. So the slope gets multiplied by a 1 if we're making a predicted outcome for a woman, which is going to bring her score down by 3.6 points in this test. So the 1 group is lower than the 0 group is what a negative slope is giving us. Likewise, the future group is lower than the none group, future relative to none by about 5 points, and the current group is lower by 16. And so the difference between those two groups would be a linear combination I could ask for to get a significance test that goes with the difference of about 11 or so, which I don't remember if I did that. I don't think so. So then we're making pictures. So here's the code to make pictures if you wanted to show those predicted people. Parallel lines is another way of indicating that the same predictor effects are expected for everybody. Here's the Stata code to do the same thing. Stata has this lovely command called margins that replaces all 9 of the estimate or lincom statements because it allows you to specify a range of predictor values for which you want predicted outcomes. So the way that these numbers here are interpreted, the first number is where do you want to start from in your range? The last number is where do you want to finish? And the middle number is the increment. So by what? So this is saying start at -5 in increments of 5 and stop at 5. So that's going to generate a prediction for -5, for 0, and for 5. Likewise, we're starting at -3, going in increments of 3 up to 3. So all 9 possible combinations is given by this one line of code and a picture. So the only difference in the SAS output is that the constant is at the bottom of the list, which drives me nuts, and I haven't figured out how to change it, if that's possible. But that is common for all the Stata procedures that all do that way. And there's my picture. Okay, so page 5, giving you a signpost. For homework 6, look at this one. I figure the last week of the semester is not the time to be subtle. Go to this page. Write that down. Page 5. This is your model. So this is what it would look like to have a model in which there are 2 interaction terms with a binary predictor. So it's men versus women in this example. It will be easy versus hard opponents in your homework. So this is interacting with age and grip strength. Yours will be interacting with verbal ability and spatial ability. So the format is very much the same. So I am keeping all of the predictors that were in the model before, just like you will. So you'll start with the main effects model in section 1, and then you'll add these 2 interaction terms to it. And interaction terms in SAS are indicated with an asterisk. Interaction terms in Stata have a hashtag or a pound sign. In terms of the rest of the code, there's nothing new here. This is an example of a contrast that would generate an F-test for the change in the R-square resulting from my 2 new interaction terms, just like you did in homework 5. Same exact thing. Here's another example of an F-test that lumps the 2 dementia contrasts together to get an overall test of group. So that's something separate, but you can do that as well. And then how to get what the model says the effect of the predictors would be as a function of gender as the moderator. So what the model is saying with these 2 interaction terms, it is allowing the effect of age and the effect of grip strength to differ between men and women. That's what these interactions are saying. So if gender is the moderator, then we might want to know 3 things for each slope. So if I start with age, what is the age slope in men? What is the age slope in women? And are those slopes different? The model is going to give me 2 out of the 3, and the third always can be found as a linear combination. So here's what we practiced today. If I want the age slope, step 1, go to the equation, find all the terms that have age in them. So I need beta 1 and I need beta 6. So that's where I got this far. These are my ingredients. This is how the model tells me what the age slope is going to be for any gender as the moderator. I then factor out age, and what's left in brackets is what I have to tell SAS or Stata to get for me. So beta 1 is the main effect of age. At a minimum, I need that. So that's why I have age and a 1 after it, because I need 1 beta 1. And then for the interaction term of sex by age, I am plugging in the value for the gender as the moderator. So if I want it for men, given the way I have coded this variable, men are the 0. If I want it for women, they are the 1. So this first line right here, technically I didn't have to write. It's not a linear combination. It's just beta 1 all by itself. The second line is a linear combination of the age slope plus the interaction of sex by age, and so I did have to write that one. Okay, with me so far?
Actually, can you repeat that? I don't understand why for the men it's not a combination and for women it is.
Because for men, the 0 here means this entire term would drop.
Oh,
And so it's just one number.
okay.
So I'm doing this for pedagogical purposes, but I also actually do this myself. Even though this is redundant with the output, when I come back to this 6 months later, I'm going to appreciate the label age slope for men. That's what this means, because I won't have to figure it out again. Plus, I like having all of the answers in the same place. Likewise, gender by grip strength. Same set of operations. Start by finding all the terms that have grip strength in them. Factor out the common grip strength variable, and you're left with a linear combination. So in this case, it's the main effective grip plus how it is moderated by gender, 0 and 1 for the men and the women. And then predicted values. So I'm going to ask you to practice this as well. So because I'm asking for a predicted value for particular ages and grip strength, everything goes into the model. I'm holding constant dementia group at 0 for all of these lines, but everything goes in otherwise. So intercept 1, because at a minimum, to create a predicted outcome, I need an intercept. Then I need to know for what kind of person am I creating a predicted intercept. This is for men, so that's why gender is coded 0. The predictions for women, switch this to a 1. I'm holding age at 80, so relative to the centered value, that's 5 lower. Likewise, I want grip strength at 6, relative to the centered value of 9, that's 3 lower. And because I put a 0 here for gender, 0 times minus 5 is 0. Likewise, 0 times minus 3 is 0. So the interaction terms are zeroed out. The only lines in which the interaction terms take on values are the lines for which we're making predictions for women, in which gender is coded 1, and then it's 1 times whatever the value of age is, or 1 times whatever the value of grip is, that creates the values of these interaction terms at the end here. Stata code looks very similar. Here's my 2 new interaction terms in Stata with a hashtag, C dot in front of them to make Stata do math. Here's my test statement. That gets me my F test for the change in the R square resulting from my 2 new interaction terms. And then my simple slopes, as they're known, are Lincom statements. What is the thing I'm asking for? That gets a 1. And then for which group do I want it? Men versus women, a 0 versus a 1. And the same thing for grip strength. And all of those estimate statements to create predicted values you can do in one line via margins. It's beautiful. I wish SAS had this. All right, so we're out of time for today, but we can go over the output next time, and then you'll have everything you need. All right, any last questions before we adjourn? All right, then I'll see you Thursday. Let me know if you need anything. Office hours at 3:15. So hang in there.